Okay, good evening, everybody. Let us start our lecture tonight. How was your test? Test 2? Horrible. Huh? Attention, please. Sorry, this room is hot. So, how was the test 2? Alright? Okay, like test 2 and test 3 and in final, you will not be allowed to write pseudocode. You know, for test 2, we get 2 questions, right? To write an abstract class and an interface. To write actual code, okay? For instance, if you write print, then I will understand you wanted to write system.out.println in Java or console.writeln in C#, okay? That is allowed. But we will check mainly if you understand how to declare an abstract class, how to declare an interface. So what is an abstract class? So inheritance. Inheritance is a class, the data type, or a method. No, it is a technique. Okay, I clearly discussed this. Okay. So I clearly mentioned it in the lecture. That inheritance is a technique or a process through which one class inherits or acquires properties from an existing class, right? This is the way we reuse properties. Is it a technique? Or process. Or process. Whatever you say, it's okay. But inheritance is not a method, inheritance is not a class, inheritance is not a data type. There are 2 correct answers over there. Anyone, if you write, there's correct. Okay, so now let us see our schedule first, as usual. So far we have completed until recursion. Anyone has any question about recursion? Yes.
Are you going to put it up on the screen?
Oh, sorry. It's coming? Yes. Sorry. Okay. Sorry. So far we discussed recursion, right? Recursion is also a process by which a method calls itself. Okay? And when a method calls itself, that method is called a recursive method. And the process is called recursion. Or technique, this technique is called recursion. Okay, so today we are in the second half, actually last third of this course, okay? So we have completed object-oriented principles, and then we have discussed GUI programming, string operation, reference parameters, and recursion. And today we will start a new chapter, linked list. Actually, linked list, stack, and QE. These are data structure. Data structure means how data are stored in a computer memory. In general, when we say computer memory, then we mean RAM, random access memory. Okay. Initially, when you write a program, when you create a variable, it takes place on RAM, random access memory. When you save that value in a data file, that value is saved in permanent memory that we call hard drive or floppy drive, right? So if otherwise not mentioned is hard drive or permanent memory or secondary memory, then you assume that we are talking about memory means RAM, random access memory, that is volatile. As long as you close your program, data is gone. In order to save this data persistently, you need to do file operation. We will discuss in last quarter file input output operation. Okay, but today we will learn data structure, how a new kind of data structure. Basic like variable, right? There are 8 primitive data type. Okay, integer, float. So integer, short, actually byte, short, long, integer long, float, double, that is, and boolean character, and there is also string is built in but not primitive. Okay, and we also know how to create a new data type, right? That is called class. Okay, and linked list is a data structure. For instance, we know one kind of data structure that is called array. An array is a data structure. Okay, how the structure means how data are stored. In an array, data are stored. Listen to me, please. In an array, data are stored sequentially, right? One after another, right? All data in an array stay together, close, right? Sequentially, one after another. Okay. So there is other kind of data structure that is called linked list. So by looking this name, we say linked list, right? That means there will be list that will be linked together. It's kind of chain, okay, or chain. Whenever we chain, we see chain. How do we see chain? Like so. If we have a chain like this, in a chain, like the rings are connected together, right?
Yes.
Like this, right? So each ring is connected together, right? So whenever, so if this is my starting point, then if I want to expand our ring, then it will go all the way, usually all the way next. But sometime if I want to put a ring here, then we need to expand, we need to create a space, we need to move this ring forward, and we need to make an empty space over here, and we can add another ring over there, right? So here in a like ring, so for instance, these are in a chain, these are called ring, right? Okay, and if we consider that in a data structure that is called linked list, then we will call these as a node. These are node. Okay, so in a linked list, these nodes are connected together, connected each other. Okay, so each node knows, so like this node knows who is next to it. Okay, this node knows who is next to it, he knows who is next to it, and if it is the last node, then he knows there is no last, so he knows that this is the boundary, and he knows this is called null. This is called null value. That means whose next is null, that is the terminal point. Like sometimes we have some houses in a gated community, for instance, okay, or an apartment, right? For instance, in an apartment or a gated community or university dorm, there are some rooms next to each other, right? Okay, usually the rooms are numbered 1, 2, 3, 4, 5, or 101, 102, 103, or maybe 101, 105, 107, something like this, right? So there is a sequence they maintain. So this kind of data structure, okay, so initially this seems to be a little bit difficult for you to implement, but if you give attention and if you understand the underlying concept, how this kind of data structure is created and accessed, then it will be easy. But you need to give attention. If you do not give attention, you will not understand. And for this week and next week, whatever we discuss, linked list, stack, and queue, if you do not understand tonight's lecture, you will not understand the next thing. You will not understand. It will be difficult for you, okay? Because whatever we'll discuss tonight, that is related to also linked list, stack, and queue, and also for other parallel, say at least we say linked list, stack, and queue. These are the contents for actually data structure course. advanced computer science, one of the advanced level programming computer science course. If you take your major as computer science or software engineering, then you have to take a data structure course. And in order to take data structure course, you need to get a B in this course, right? Okay. So actually in many universities you will see that they do not teach like this linked list data structure element. But these are the foundation that you will start with your next course, data structure course. But in this course we will give you some basic idea so that you have prerequisite knowledge how like other data structures are built. That will be your main topics in your data structure course. Okay, so please give attention, everybody, please give attention. Unless you give attention, you will not understand, and if you do not understand today's lecture, it will be hard for you to understand this completely test 3. Okay. So let us see our so far we have completed recursion part 2 until this, and linked list. Lecture 14 is our today's topic. Okay. So a linked list is a dynamic data structure. So at least one kind of data structure, you know that there is an array. An array is called a static data structure. That means, you remember that when you declare an array, you have to declare its size, right? For instance, if you declare an array, then you have to declare its size, for instance 100 size. And if you have 101 data, 101, if your list size is 101, you cannot store 101 data and in this list, because you then store means that you have to terminate your program, or then you have to expand the size. Okay, and after that, but you know, we frequently use many apps. For instance, we frequently use many apps, right, in our phone and the computer. So if you do not have access to source file, then you cannot expand or extend data size, array size. For instance, if you remember that if you use old kind of phones, small phone set, so that kind of phone set had restriction that you could save only maybe 300 or 360 or maybe 200 friends' name and number. Remember that? Because those are developed with a static data structure, maybe an array. So you could not save more numbers or more contacts in your friend list. Okay, but today we use our smartphone, right? You can save many numbers, maybe 1,000 numbers. I don't know what is that maximum limit, but I have maybe several hundred numbers in my contact list, right? Maybe you have. So these are developed with dynamic data structure. For instance, if you download an app that, for instance, that will allow you to save your contact, but if that has a static size, fixed size, 100 or 500 maybe, right? So after 500 you cannot add more friends in your list, right? So because you don't have access to source code, you cannot use that app. That is a problem, right? So in order to resolve that problem, there are some dynamic data structure. Dynamic data structure that is called linked list. So linked list, that it has no ending point. So whenever you declare a linked list, you do not have to fix its size. You can put only one data, or you can put as many data as you need. Think about the limitation of a static array. For instance, if you declare a static array, normal array, one-dimensional array, two-dimensional array, okay, with 1,000 size or 1 million size, but you have only 10 data, then the other memory spaces will be reserved for that array, and you cannot use another program to use that memory space. So there is a possibility with static data structure that you may misuse your data, your memory, right? or you may be out of your memory space, or you may misuse your memory space. You may have some empty space, so your program will be slower, but you are not using, you cannot use this space. So in order to resolve that issue, so there is a dynamic data structure. One of this data structure is called linked list. Then there is a stack and QE. Okay, so there is also in modern programming languages, there is also a built-in data structure, built-in linked list, that we say called array list. Remember that I asked you to watch a video from my previous so because on the review side there was a video that I asked you to watch. YouTube, this video. Let me ask you. Welcome to the. I asked you to. Okay, I asked you to watch this video. So if you have not watched it again, please watch it again. Okay, this is the right time you need to watch it, because in this video you will see that there is a built-in linked list that is called array list. Okay, that is already available in Java and in C#. But in this course, in this week, you will learn how to build this kind of data structure, how to build your own array list. You will learn, okay? But in your test, you will be asked to build your own data structure. You will not be allowed to use built-in data structure. So this is the built-in array list, okay? So there is already available. Then you may ask question, why do I need this to learn, right? You need to learn how this data structure is developed. How can you develop a new data structure? Okay. So everybody, if you have not watched it, please watch it at one time, okay? Okay, so in a linked list is a linear collection or a sequence of nodes. Okay, what is node? I will come back soon here. Okay, and connected by reference, that is linked. This is a chain together. A linked list is appropriate when the number of data elements is unpredictable, when you do not know ahead of time how many data you will save. Okay, if you do not know how many friends you will have, then you need to use linked list. Okay, so linked list become full only when the system has insufficient memory, otherwise it will not full. That means insufficient memory means your RAM is limited. Maybe now today that is not an issue. With the sample program, what we will discuss, it is not an issue. So that might be issue for a normal computer. For instance, if we want to save, this is the time for census, right? Census 2020. So that government is getting all people in the USA that records. If you store, maybe there will be more than 300 million people. So if you want to save that large number of data in a small computer, that will be an issue. Maybe you will get out of memory. Otherwise, for small program, you will not have insufficient memory. Okay, so do not worry about insufficient memory. So the main element of a linked list is called node. So what is node? Okay, a node is a class or an object. Okay, a node mainly an object that contains a reference of itself. Okay, a node is an object that contains a reference of itself. What is that question? What does that mean? Reference of itself, that means it knows who will be next to it, who is next to it. Okay, so maybe in some communities there is a community leader, right? So maybe if you have a gated community, maybe they have a president, right, in that community. The president may know that who are the householders of this gated community, right? So that if there is a rule that in order to enter into that community, you need to get permission from the president of that community. Okay, and then everyone, if there is a new member on that community, if the new member needs to go to the president, and president will tell him where the new member will reside. The president will tell that that guy is the last person, you go next to him. Okay, so a node is an object that contains its own reference. Okay, we discuss reference, right? We discuss reference and we discuss object. So reference, when you say reference, that means it is a kind of object, but that does not create new object. So there is no new operator over here. So you say this is type. So here class is node. That means node is a class, means data type, right? And whenever a node contains another node, okay, that this next is name is next. So this next is not an object. This node is a reference of what kind? Of node kind. So node, that means is kind of recursion, right? We know that in a recursive method, a method calls itself, right? But here a node does not call itself, is not an object, but it contains itself. Okay. So this class, node class, can contain any data, can be developed with like as a regular class. Everybody know, right? Everybody at this point, everybody knows how to declare a class and how to access. So this is a node class and it has public member, only one public member data, right? And it has also another public member that is called next of type itself. Everyone understand this? And this node next is the key element of a linked list, because this next will know who will be the next person, next node to it. Okay, so that will connect, this next will connect, will know that who is the next, this node, every node knows who is next to him. Okay, the last node, who is last node, he will know that there is nothing next to it. That means there is null. There is no actual node, but there is null. Okay, so that means what is a node? A node is an object, but regular object, in addition to holding regular. So a class, what does a class contain? A class contains some variables and some methods, right, to access those variables, right? So in order to normal variables and method, it also contains one more extra reference of itself, then that is called a node. So everybody understand node? Okay. So a linked list can be, okay, I discussed that. It can be a chain of linked node. A node is an object with mainly two attributes. One is data and another is the next node in the chain. For instance, the object in a linked list is like this. For instance, a node will contain some data and another part in a data that will know who is next. Okay, so this is how it will be connection. So this part, so for a node, this part contains data and this part contains the address of the next node. Okay, so like for instance this, and this part, whenever it says, that means this is terminal, and there is no next. So this is the terminal. Okay. So the main challenge to create this kind of data structure is we have to define a node. Okay, so the first node is called head. Okay, so in order to go to the third node, we will start from head and we will say that head dot next. If we say head dot next, then it will mean this second one. And if we say head dot next, then it will go to the third one. So if I say Karen, your name is Karen, right? If I say Karen, please call the person next to you. Then whom do you will call? Yes, he. Okay. So if I tell you that call the person next to you, then the person, what is your name? Parker will be. You will find Parker, right? So you understand? So when you say this is head, who is in the top at the beginning, and if we say head dot next, that will mean this guy. Okay, second one. Okay, if I say head dot next, then it will go to the third one. If I say head dot next, then it will go to the fourth one. You understand? This is the way it will go. Okay. So in order to go to this node, we have to start from the beginning, right? And we have to start from here, head, then we need to go to the second node, and we have to go to the second node. There is no way to jump to a node, but there is a limitation in array. We know how to use array index, right? In order to go to an element, if it is a regular array, then we can use index in order to jump to any element directly, right? So accessing an array element from any point is easy, but here in linked list you must start from the beginning, and you have to go starting from here to here to here, like this, sequential. You cannot jump. Okay. So that our main goal will be how to create a linked list, and in a linked list you will see that there will be link. So when we create a linked list, okay, in order to create a linked list we have to create a node first. Okay, then we have to insert data. Okay, so but there are two kinds of insertion. Okay, first one, you can insert at the beginning of your list, or you can insert at the end. There are two kinds of insertion. Okay, you can add at the beginning or at the end. Okay, so for both cases there is a problem. So if you want to add a new node at the beginning, that means you are changing your head, right? You will have a new head, right? Your old head will not be head. That will no longer be your president. You will have a new president, right? A new head. Okay, you have to change your head, and if you add at the end, then you have to change the terminal point. Who was previously the last node, that will not be the last node if you add at the end, right? So that is the, if you add at the beginning, that is called a prepend. Okay, if you add at the end, that is called append. We will discuss this. Okay, and there is another kind of insertion. If you want to insert at the middle between two existing nodes, right? So if you want to add any element, you can add at the beginning, you can add at the end, or you can add from the any point, right? So there is three kind of addition. Okay, but normally if you want to add at the beginning, that has a name, unique name, that is called prepend, and if you add in the end, that is called append, and if you want to add any point in between, that is called normal insertion. Okay, three kind of insertion, we will know this. And then delete operation, we need to delete operation, right? For instance, we can delete the first node. If we delete the first node, then we have to change the head, right? In a linked list, there must be a head. So if you delete this one, this node, then you have to make this one as a head, right? But if you delete from the last one, then you do not need to change head, but you need to change tail. The tail will be joined here, this node, right? And another kind of deletion, you can delete from the middle, right? If you delete middle node, so then this node needs to be connected with that third node. Okay? Yes.
If you have an odd amount of nodes, does it fall front or behind?
I don't understand your question. What is that?
If you have an odd number of nodes and you put another node in the middle,
That does not matter if you have odd number of nodes or if you have even number of nodes. Matter is that where you are inserting or from where you are deleting, either from the beginning or middle or end. It does not matter if whether, good question though, whether you have total existing number odd or even. That is not a matter. The matter is position. Because if you delete this one, right, you have to change head, right? If you delete last one, you have to change tail, right? Okay. And there is another kind of operation called search operation. You want to check whether an existing data is available in your list or not. Okay. How can you check? This is search. You have to do iteration. You have to start from the beginning. If you get match, then fine. If it does not match, you need to go to next, right? Otherwise, you need to go to next. Okay. Their search is called linear search in an array. So in an array, how do you search that whether an element exists in an array or not? You start from the beginning, right? Normal search. You start from the beginning, and then you go all the way starting from the beginning, and you proceed all the way by index, increasing index one by one, check one by one if your expected value exists or not, right? If it does not exist, then you have to go all the way in, right? If you start from the beginning and if you go all the way in, and if you do not find your element, then you say no, it does not exist. But until you go to the last element, you cannot say that it does not exist, right? But in another case, if your list is already sorted, then you can go at a certain point that if you see that your value is not available within the range, then you can say it's not available, right? But that is for normal array operation. But the sorting algorithm we discussed, right, in 1321, and that is sorting, but this is different. So common operation we need to, another operation is called sorting. So if you want to sort these nodes by value, for instance, we'll discuss this. Okay, so this kind of operation mainly we will learn how to do insertion, deletion, and searching. Okay, so if you understand this, then you will get an idea, and when you take your data structure course, you will learn more. Okay. Let me discuss this. For instance, you have an original node that has values 7, 5, 8, and 2. So if you want to add a new node 6 with 6 value, okay? So that question is that where do you want to add that 6? If you want to add that 6 at the beginning, right? So then this 6 will go here, and then head will change here, right? This 6 will be a new head. When you do program, then you will understand this. Because if you want to add a 6, the node 6, value 6, then this one will be your new head. And whoever was your previous head, he will no longer be head, he will be regular node. Right? So, like a linked list, consider it as a community, gated community, where there is a head of that community. Okay, so everybody comes to join in that community, he must first go to the head. Okay, and there is another special who, and then there is another criteria that everybody will know who is next to, who is his next neighbor. Okay, so now in this world we live in a society that maybe we still do not know who is our next neighbor, right? Do we everybody know? You know who is the next neighbor? You know who is the next neighbor?
In the seats?
No, at your house or home.
The Browns.
The home. The home where
The
you live.
Browns. That's right, that's her name.
Maybe some of we know, some of us still do not know, right? Who is our next neighbor? Okay. But in a linked list, every node knows. An ideal society is an ideal society. Like every node knows, every householder knows who is next to him. Okay. Okay, and so for instance, deletion is like this. For instance, if you want to delete this node, one node, then you have to relink. Yes.
You say every node knows its neighbor. Does it know both the preceding and the following?
No, and they only knows the who is next. Okay, so there is two kinds of linked list. Okay, is called singly linked list and doubly linked list. Okay, so this link is by default is called singly linked list. That is singly linked list. It already knows who is next to him. Okay. Yeah, who is following? Okay, and there is another kind of linked list that is called doubly linked list that knows who is both sides. For instance, let us start there. Let us think that he is the head. What is your name, please? Michael is the head. Okay, Michael knows only who is right side to him. So Michael knows that Michael's next right is Karen, right? Karen knows that. What is your name? Alan is her next node. Okay, and you know that he is your next. Okay, and he knows that he is your next, and he knows that he is next, and all the way in he knows that he is the last one because there is no person. Next is empty. Okay, that is called singly linked list. Okay, it is nature, this by nature. Okay, but it may have a doubly linked list. That means every node knows who is next, right side to him or also left side to him, right? In that case, Michael would know his left side is null, empty, but right side is Karen, right? So there are two linked lists. So first of all, yes.
Does that mean the head knows the tail?
Yes. So far we are discussing. Let us understand a singly linked list. Then when you understand singly linked list, understanding doubly linked is easy. Okay. So far I want to make sure that you understand what is a node. Okay, a node is an object, okay, that contains its own attributes and also it knows who is next to him. Okay, how do it knows that who is next to him? Actually, it contains another reference of itself. Okay, so now maybe we are good point. So at this point, so for instance, a linked list is a class, so we will create a node class, and this is, since it is a class, it can contains any number of attributes and it can contains constructor, other methods, and the main thing that it will contain another linked. So let me go to a live program, and then when you understand how to create a node, that is the main challenge. Then we need to understand how we can understand how to create add method, how to add in the front, how to add in the middle, how to add in the back, how to delete, okay, how to search. Okay, so the main thing will be, so the as you know that the main thing will be, challenge will be to understand how to create a link, a node. Okay, then how to create nodes. Okay, so my complete program, give me a second. So at this point, how many of you know GitHub? Good amount of people know. That's good. You don't know, Michael? Okay, this is a good point that you should learn GitHub. Okay, so you know, if you know GitHub, you are one step ahead. You may see that many maybe graduate student or senior, they do not know how to use GitHub, but if you know GitHub, then you will be one step ahead, right? Like a virtual drive that you use OneDrive, everybody, right? Everybody, right? Use OneDrive, right? How to? So if you go to my GitHub account and see, we have CSE1322 review _ Java and _ we have also C#. Okay, implementation is same. There is no basic difference between C# and Java implementation unless print statement. Okay, and some basic. So if you know how to create a class in C# or Java, you should be able to do this. Okay, so my complete project is over here. Here, if you go to my source, and then you see that I have doubly linked list that we'll discuss later, but I have singly linked list. What is that? Okay, singly linked list. Okay, let's go. So if you go to this download this program, so then it has, you will see that it has a class node and it is called main class. Okay, you see from that, you see whole page. Okay, let me open this in my Eclipse. Okay, for this one I want to use Eclipse. Okay, so here I have singly linked list. I'm not sure if I have a program in Replit. Okay, I have also singly linked list in Java. Okay, I can go with it. Which one you like to use? Use Replit or use Eclipse? Huh? You like me to explain with Eclipse, or at this point everybody should be used to using Eclipse. Okay, Eclipse or NetBeans. Okay, no company will use Replit. You are getting prepared for an internship or job, right? Within 2 years you will go to a job, or soon you will go to an internship. So you really need to be used to using Eclipse and GitHub. Okay. So this is a node. A node is a normal class. Okay, a class, what does a class contain? A class contains some variables, right? For instance, integer type variable ID and name. So if we understand with these two types of variables with a class, then we can add any number of other type variable, right? We can add, for instance, I have ID and name. I can add another float type, weight or height, right? I can add another, or boolean type, is active or not non-active. So any variable I can add, if we understand this. Okay, so give attention everybody. Now at this point I really like everybody to give attention. Yes, please close your other business for the next 20 minutes or 30 minutes, then 20 minutes maybe, right? Then really you will learn something. I like you to understand this, otherwise you will not understand the whole this chapter. Okay, so this is our node class. A node class, it contains a class is a regular class. It contains some variables, right? These are the variables, right? and in order it contains some methods. So this is my constructor method, right? Okay, this is a node class and it is a constructor, right? Okay, and it can also contain other methods. This is my other method, and it can contain any other method. This is my toString method. My toString method, it displays a node. Okay, and one extra thing, a node contains a reference of that node. This is the main difference, main attribute of a node. Everyone understand what is a node? What is the main special attribute of a node? What is special in a node? Okay. No, so you can say these are ID and name. These will be used to hold ID and name, right, for an object, right? So this is the special node. It is contain another node, right? This node is next. That means I can give any name, but this is my object name, right? Node. So we are not using new operator to create this. Okay, so this is called its reference. So I can say public. I can say public, or I can keep it by default. That is in C# you need to make it public, right? Okay, and other thing is simple. For instance, displaying a node. This is how we want to display node, and to override the toString method. You understand about why do we need to override this toString method, right? You understand? And this is the method for simple method, but only exception is that, and addition is that here I have another node element that is called next reference. The reference to the next link made the linked list. It holds the reference to the link that was created before it, so that the next set to null until it is connected to other link. I will discuss this, okay, soon. I have reference. So this is that's it. My node class is simple, okay. So if we understand a node class with ID and name, if you understand with this, you will understand any kind of node. You can add any kind of new variable here, right? In your book, maybe you will have only one variable. They're working with only ID. So I have added ID and name. I can add other variable. So far, anyone has any question about node? If you understand what is a node? Yes.
When you see that you insert something, like you said, like 7 was the head, and you insert 6 where 7 was, does 7 come out of the node sequence?
I will go back to that slide later. Okay. So when we go live program, then you will see, you understand the better. But for instance, so far I'm asking, do you understand this class?
Yeah.
Then fine. Okay, we will go back. That remind me if I forget. Okay. So far we understand that we have a node class that has a special element, that is this one. Okay, now I need another class, any class. For instance, I can give another name, any name of this class, but people usually give, or I usually give another class name that is called linked list. Why do I need this class actually? So in this class we have only node. We create node, right? Okay. So then we need to later, for instance, let us go to my main method. Here I have main class. So main class, let me forget about this. Let us go to my main method. Don't worry about the big large program. You need to understand line by line, okay? So then this is my main method, right? So in the main method, how can we create a node object? It's simple, right? Node n1 equal to new node. For the node, every node, it has ID. I'm giving ID and name, right? For simplicity, let me give ID equal to 1 and name equal to n1, because we have constructor for our node class. What is the constructor for our node class? is it takes an ID and a name, right? This ID, it takes two parameters. This first value goes to ID and second value goes to name, right? So then if you understand then everybody understand this statement, right? What I am doing over here? Creating some nodes, creating some ring. Okay, so in a linked list, like I want to create a linked list like this, but initially I am just creating some ring. I'm just creating some ring. Not these ring are not connected yet. Okay, I am just creating some ring. There are individual ring, right? Okay, so far if I create this node n1 and n2, n3, n4, n5, n6. Okay, then I have another method, display a node. So how is my display a node method? So just it displays a node ID and name. Pretty simple. Everybody understand this statement, this method?
Yes.
Simple, right? Just I'm displaying a node, right? An object value. Okay, and I have also two string method overwritten so that it displays my object as a string format. Okay, so if I run my program up to this, if I run my program up to this here, up to here, I'm giving a boundary. Okay, so like this. So everybody, so when you see the output, do not look at the output below this line. Okay, only look at output above this line. So we have some display statement, right? So if we run this program, how far I will see my output? Before this line, right? Before this line, right? Before this line, right?
Yes.
So what it is displaying? The first one, n1, for the node n1, ID is 1 and name is n1. Okay, sorry, ID is 1 and name is n1. And the second ID is 2 and name is n2, right? And third one, ID is 3 and name is n3, and so on, right? So everybody understand that this is the output, these are the output for this statement. Everybody understands? Clear? Okay, if you do not understand, raise your hand, I will repeat. But if you do not understand this, you will not understand next steps. Okay, why do we use two? Good question. Why do we use two string method? Okay, let us remove this two string method. What will happen? If we remove this two string method, what will happen? Do we have this two string method? It will send me this address, right? So actually I do have this is also working for like two string. So if we use two string method, for instance, not to display the object location memory address, but to display the actual object, right? We use two string method to display an object in string format. That is a basic question. We discussed two string method in one of the test one. We discussed this, right? There's a test question, right? Two string method. Really good idea. So in your test, if you miss something, review that. Okay. That you think that you should know. Okay. But here, so far everyone understand this? Do you understand this? Now, what is the fact? So we just created some node. Okay. So these are the individual node, but the problem is that these nodes do not know who is next to them. So these are the people, they live in not an ideal society. In an ideal society, we say that people should know who is next to them, right? Who is a neighbor. Do you have few more minutes that I could finish at a certain point today? Or Give me a few more extra minutes, okay? Then I can finish certain point. Okay, so for instance, if I print, say, if I say, you see that every node, it contains another is a next element, right? Attribute name is next. If I say n1 dot next, so what do you think it will print? Because the node 1 does not know who is next to it. Okay, so let us see output before this, after linking the nodes. So these nodes are not linked yet. So now if I run this program, I will see output. You see that n1 dot next equal to null, n2 dot next equal to null, n3 dot next equal to null, like n6 dot next equal to null. That means these nodes are independent. These nodes do not know who is next to them, okay? But we want to develop in a society or a data structure in which every node knows at least who is next to it, right? So in order to do that, we need to connect a node, right? So we need to teach Michael so that Michael knows Karen is next to Michael, right? We need to teach Michael, right? For instance, let us think that this node is n1 is Michael and n2 is Karen. You will not mind, right? Okay. So then we need to teach every node who is next to them. How do I teach them? So we say n1 dot next equal to n2. I need to tell Michael that, hey Michael, your next one is n2. Okay, so this is the n1 dot next equal to n2, and I need to Karen tell that Karen, hey Karen, your next is he. Okay, so this is way that we will link. So you say n2 dot next equal to n3, n3 dot next equal to n4, n4 dot next equal to n5, and all the way. If I want to make n6 is the last node, then n6 dot next equal to null. Yes. Yeah, at some point we have to stop, right?
But it already has it.
No, we have to stop it. At some point we have to stop it. We have to terminate it, okay? So this is how we connect. So after we connect, if we see that, if we execute this statement, then you will see that every node will know that n1 dot next equal to this node. So this is coming from, since I deleted the toString override. So this is why it's coming over here. If I run it again, it will give me. So in this page, after linking, it will show n1 dot next equal to 2. Okay. Okay, n1 dot next equal to 2, and this name is id, and n2 dot next equal to 3, n4 dot next equal to 4, and something like n6 dot next equal to null. Okay, so far whatever we have done, we created a node class, and in our main class we created some node object, right? And then later we tried to display the node, but we noticed that these nodes are independent. These nodes do not know who is next to each other, right? So then that is the next step. We wanted to connect. We wanted to teach every node who will be next to it, right? So this is how we linked each node by doing, for instance, this n1 dot next equal to teaching. By we're teaching them who will be next, right? I can give this sequential order, or I can give any order. Okay, after that, if I display this, then I find that, okay, every node knows who is next to it, right? This is a naive way, traditional, non-traditional way, that when we create a node, we teach the node who will be next to it. But in our next lecture, we will learn that when we create a node, automatically it will know who is next. Or actually who is parent or adjacent. Okay, so if we can teach a node, if we can, at the time when a node is created, we need to teach the node that who will be his next or previous. There is the implementation part, how to implement a linked list. Okay, so far whatever I discussed in this lecture, if you remember this, okay, then my next part will be easy. That in our next lecture we will discuss that how we will create another class. For instance, here you will see we will create another class that is called, I say, linked list class, and this linked list class will contain all the method for insertion, deletion, and other linked list operation. Okay, next class, next lecture will be crucial. Do not miss your next lecture. And then our next lecture we will start from 6:50, right? I said. And then after that, okay, so from next week we will start regularly, okay? If you understand our next lecture, then you will be able to implement anything, okay? 2 weeks.
2 weeks? Alright.
I have a question about this week's assignment.
I need this.